Okay, so yesterday we looked a little bit at areas. So if we had a rectangle such as this, its area would be its length times its width. So you could call it either the length times the width. And area of this is then length times width. So you don't need to take a note on this. This is okay. You already have this in your journal. So this is a two-dimensional shape. So this has two dimensions. Two dimensions. One dimension is length, and the other dimension is width. For instance, one dimension is when you're just dealing with length. So for length, so one dimension, when we're dealing with maths, we ask for something like perimeter, which would be the distance perhaps around the outside of a shape. So we haven't talked about that much yet, but we will come back to that. Perimeter, the distance around the outside of a shape. So that's a distance, a length, that's only got one dimension. Two dimensions then moves into, of course, when we deal with this in maths, we talk about areas. Perimeter would be measured just in centimeters. If it was, that's the unit we're using. If we're using centimeters in area, it is centimeters squared because it's centimeters times centimeters. Now we're moving on to the third dimension. Three-dimensional shapes. Okay, and that is when we add another dimension to this. And our word we talk about when we're talking about third dimensions is volume. And that's measured, well, we are looking at now length, width, and depth. Or we call it length, height, and depth, or length, height, width. We're dealing with three dimensions. And that is measured in cubed units. If it was centimeters, it would be centimeters cubed. Now, how do we calculate this? And I'm sure, okay, hi Ezra, I'll mark you as present. Okay, so if area is length times width, we can get the area of a front of this shape. This shape is called a prism. Does anyone know the definition of a prism?
Is it a 2D shape pulled back and forth?
Yeah, so a 2D, yeah, that's not a bad explanation. Yeah, so a prism is, it's a three-dimensional shape that keeps its form throughout, yeah. So you can move this two-dimensional shape throughout the shape. In other words, you could slice it anywhere, and the two slices, if you were to open it up, would look the same. So think of a very rectangular loaf of bread, and you were slicing it, and every single slice looks the same. So every single slice of this box would look the same. And if it does look the same, it is a prism. So another example of a prism perhaps could be if you ever see a triangular prism, which would be, I can start a prism by drawing the same shape twice, just further away from each other, and then just joining the corners that match each other. That's how I draw a three-dimensional prism. So and you can test for that. If you draw the same shape twice and join the corners, that you can make a prism. So a pyramid, for example, would not be a prism because the slices would be different. But a lot of things like cylinders are often prisms. Boxes are definitely prisms. A shape like this, which would be the wrapper maybe out of a Toblerone. Not the Toblerone itself, because that has slices in it, has like dips in it. But the wrapper of the Toblerone, you could slice it at any point and it would still make a triangle. So this, what we have down here, is called a triangular prism. And this is a rectangular prism. and both would have volumes. So I would like you, if you haven't already taken a note on this, from below the line, to have your best go at drawing your rectangular prism and triangular prism. So create this in your workbook if you can. Now, if you want help drawing that again, if you want to draw a rectangular prism, draw two rectangles. One somewhere on the left, and then one maybe a bit away above it. Draw the two rectangles, and then join the top left corner to the top left corner, top right corner to the top right corner, bottom left corner to the bottom left corner, and bottom right corner to the bottom right corner. So you just draw the two shapes, and then try it. So give it a go. See, can you draw a three-dimensional shape on your two-dimensional space, which is kind of cool. So you're trying to create that 3 dimensions on a two-dimensional page. So see, can you do that? I'll give you a second to sketch at least one of these sketches. Definitely take down the words. So we're dealing with 3-dimension shape, and we measure that what is enclosed in it as volume, and it's got 3 dimensions to it, so it's centimeters cubed. All right. Okay, so on a 3-dimensional shape, then you can label the sides if you want of a rectangle. So you can go length and width and height or depth. You can call this heights if you want. So these are the different dimensional names: length, width, and height. You can put those in if you want. If I want to calculate the volume, does anyone know how to calculate the volume of a prism?
Would it be like the face that you scribbled on, the area of that times the height?
Exactly, yeah. So if you think about it, if you look at this triangle here, if I know what the area of the front of this triangle is, not worried about how far it goes back. If I know what the area of one slice is, if I just multiply it by how many slices there are in it, I've added that 3rd dimension. Yeah. So the area of the front bit multiplied by how long it is. So for this, it'd be the area of the front bit multiplied by that. Specifically for a rectangle, that is length times width times depth, yeah. But for a triangle or any other shape, it just get the area of the front and then multiply it by how long it is. So to calculate volume in general of a prism, you can get the area of the front and then multiply it by its length. And that is the volume. So I'll definitely have this in the notes. So you just have to get the area. So we dealt with area yesterday of triangles, parallelograms, compound shapes, rectangles, and then you multiply it by its length. And as Joop says, in the case of a rectangular prism, you just do length times width, and then multiply it by its depth. That makes total sense. In this area, you'd have to do half the base times the height, and then multiply it by its depth. Rectangle is probably the easiest one because you just multiply the 3 dimensions. Just multiply length times width times height. Okay, so make sure you have this in your notes. I will put this video up later. If you're missing some of the notes, you can fill it in after a while. Okay. Does this apply to compound shapes then? So if I have, for instance, a shape similar to, if I have this front, and then I try, and you don't need to draw this diagram because it's a bit more complicated. I try and join the corners, so I make it into a three-dimensional shape. Okay, so this would be an example of a step. Let's see, perhaps you can see that as a step on your diagram. If we know, so let's look at this, 10 centimeters, this is 10 centimeters. This height here is 8 centimeters. This little length here is 4 centimeters. And this length here is 3 centimeters. And we have its depth or its length going back as 12 centimeters. Okay. So we need to apply what we've just figured out. First of all, I need to check that this is a prism. That if I slice this anywhere here, that it would open up like a loaf of bread and have the same slices. So I check first, is it a prism? Do we think it's a prism? And type in the chat if you think it's a prism. Yeah, I think it's a prism too, yes. So I've looked at it, and anywhere, if I slice it this way, it should open up and it should look like this shape, the front shape, at any stage. So yes, it is a prism. So therefore, I can get the volume. So think about volume. If you want to think about liquid, think about how much liquid would fit in it if I cut a hole here in the top and try to fill it up, how much liquid would fit in it. So now remember, volume of a liquid is 1 milliliter is 1 centimeter cubed, I think. All right, but let's get back to just getting the volume in centimeter cubes. All right, so if you can do this, by the way, do type the answer in the chat faster than me. Okay, so I am getting the volume of this. So in order to get the volume of this, I need to get the area of the front bit. So if we remember what our formula was, get the area of the front bit and multiply it by its length. Okay, so this is not a rectangle, so I have to break it up. So I'm just going to sketch the front bit. So I'm going to take out the front bit and just look at it. Make sure I can get the area of it. So I know that's 10 centimeters here. So this is the area of one slice. If you want to talk about area, you think it's 384. Well, let's see. This is 3. So I'm just copying it down. Oh, Priyanka, I think it's 720. Well, we'll see. All right. So this is a compound shape in itself. So this is adding layers of complexity. So, but remember, compound shape is just 2 or more shapes that we know how to get the area put together. So I'm just going to make that into 2 areas. I'm going to just cut it here. Now I could cut it there if I want as well, but I've made 2 rectangles now. So if I get the area of these 2 rectangles, that'll be the area of the front. So let's call this shape 1 and shape 2. So area of number 1. Well, I know its height is 8, or one dimension of it is 8. I need to find this length then. So it's going to be 8 times something. Now what's this length going to be? Does anyone know? Perhaps type in the chat.
6.
You think it's 6? I think you're right. Because that's 10 centimeters total. Yeah, 10 centimeters in total, and 4 of it's gone. 4 of it's gone, so 6 must be left. 4 is gone because it's written 4 up here. So 6 is left. So area 1 is 8 times 6. 8 times 6 is 48. And that's an area, so centimeters squared. Area 2 then, 4 times 3, and then 4 times 3. So I have my there. So 4 times 3, and that's 12 centimeters squared, I think. Add those 2 together and have the total area of the front. That's 60 centimeters squared. It'll come good. Hopefully. So 60 centimeters squared. Okay. 60 centimeters squared is the area of the front here. So this whole front area is 60 centimeters squared. Now I have the area of the front. I can multiply it by its depth going the whole way back. So that 60 centimeters is multiplied by the depth, which was, or length, which was 12 centimeters the whole way back. So 12 centimeters. Multiplying 60 by 12. This is why you need a calculator for this unit. We don't need to be able to do this in our head. Perhaps you can, but it's 720 centimeters cubed, which I think a few people in the chat got. Bianca got it a good while ago. 3 minutes ago, Frank had that. So that's the cube. That's it. The x. That's the volume. Amazing. So that'd be an example of a blue level question. So I'm going to give you a Kahoot now with green and yellow level questions. See how you get on. So remember, we're only going to be looking at rectangles mostly today. There's a few triangles, but remember the same principle applies. As long as you get the area of the front bit and multiply it by its depth, you should be fine. Okay, so what comes next? Going to do Kahoot, which you're going